Good evening. We have a new comet. Only a faint one, but it's in the evening sky now, in the general area of this square of Pegasus, which you can see in the southwest after dark. And tonight, December the 21st, it is here. It's not moving very quickly, and by December the 27th, it will have reached that point. It's known as Sorrel's Comet because it was discovered by the American astronomer of that name. I'm afraid it's not going to be bright. You can't see it with the naked eye, or even with binoculars, but telescopically you can, and here's a photograph of it taken by Alan Young, and you can see the comet there as a tiny blur right in the middle of your picture, looking rather like a diffuse star. It won't, I'm afraid, develop very much of a tail, but at least it is a comet. And 1986 has surely been the year of the comet, Halley's Comet. And a few weeks ago, I attended a very pleasant service in Westminster Abbey, where a plaque has been erected to the memory of Edmund Halley. And as he died in 1742 and was one of our very greatest astronomers, I think something like that is long overdue. Incidentally, in the Halley's Comet Society, we are very careful to call him Hawley, which is probably what he called it, and do please note the new design on my tie. We replaced the old 1986 with 2061, which of course is the year when the comet will next come back. But I'm afraid that by then somebody else is going to be presenting the Sky at Night program. One very important event of the past month has been first results from an entirely new telescope, the James Clerk Maxwell telescope on Mauna Kea in Hawaii at nearly 14,000 feet. And there's the very latest picture of it. It's not, of course, an optical telescope. It's operating in what we call the sub-millimeter range. That's a wavelength of between 1 millimeter and 1/10 of a millimeter. And this is very important, in particular in studies of stellar birthplaces, clouds of gas and dust that we call nebulae, such as the Orion Nebula, which you can see below the 3 stars of the Hunter's Belt. And here are some of the very first results, and this indicates the presence of carbon monoxide inside the Orion Nebula at a wavelength of 230 gigahertz. And as a gigahertz means 1,000 million cycles a second, that is not very much. But I won't go into details now, because we are hoping to go there and see it and talk about it during the run-up to our 30th anniversary Sky at Night program, which is due next April. Doesn't seem 30 years since I started out. So let's turn now to things you can actually see in the sky at the moment. And if you've got up early, you can't possibly have failed to notice the planet Venus, which looks almost like a small lamp in the sky. And there's a drawing I made of it this morning at 7 o'clock with my 12.5-inch telescope. And it shows the crescent and a few dark markings that, frankly, I've exaggerated. But you can't mistake Venus. Not a very pleasant kind of world, but certainly far brighter than any other star or planet. And it shows phases because, like Mercury, it's closer into the sun than we are. But the other planets are further out. And 2 of those now are in the evening sky. Mars and Jupiter, and they're close together. Mars is very red, not so bright now as it was last summer, and Jupiter is more brilliant than any other planet or star apart from Venus. And they're close together now. They were in conjunction last week, only half a degree apart, and that's about the apparent diameter of the full moon. But they are now moving further apart in the sky. The conjunction's over. And Mars is going more quickly, and so every night the separation between the 2 will increase. Obviously, they are not really close together. Mars is in the foreground, so to speak. And these conjunctions are not important, although they are interesting. I may say, like many other people, I've been taking photographs of them over the past week or so. And in our next program in January, we're going to talk with Douglas Arnold about photographing the sky with ordinary cameras. And many people have been asking me about that. But after I'd finished photographing the conjunction last night, I took my 15-inch telescope and made drawings first of Mars and then of Jupiter. And there is Mars with its dark markings. That, of course, is a solid surface, and that V-shaped thing there is a lofty plateau. And then I had a look at Jupiter, on which you can see far more. And you can see there the cloud belts and the bright zones. And Jupiter is brilliant because it is a huge world, very much larger than the Earth. And let me show you what I mean. If that represents the Earth, then here is Jupiter drawn to the same scale. And it really is a colossus, much the largest member of the Sun's family. But it's not solid and rocky in the same way that the Earth is. It does have an iron silicate core, but around that are deep layers of liquid hydrogen, and then we come to the hydrogen-rich atmosphere, which is what you actually see through a telescope. And since you certainly can't land on a layer of gas, there's no chance ever of going to Jupiter, quite apart from numerous other disadvantages. One thing that's not on view at the moment is Jupiter's great red spot. It periodically disappears and is not visible now. But the Voyager probes of 1979 told us exactly what the great red spot is. It's a whirling storm, a phenomenon of Jovian atmosphere, if you like, and it's spinning round and dominates the entire part of the planet. And its surface area is greater than that of the Earth. But you know, almost everything we know about Jupiter has now been drawn from space research. The pioneers first, but mainly the Voyagers of 1979. And let me show you one very interesting Voyager picture. There we have the great red spot over to the right. But you can also see there two circular things. And they are two of Jupiter's big satellites or moons. That one is Europa, and this one, silhouetted against the red spot, is Io. And Io really is red. In fact, Jupiter has got 16 moons altogether, but 12 are very small, and it's the remaining 4 which are so very interesting, and they are planet-sized. In fact, Mercury, the smallest of the main planets, and I don't count Pluto, which is not really a planet, Mercury is just over 3,000 miles in diameter, and our moon rather over 2,000. And then look at these 4 big satellites of Jupiter. Io is just a bit bigger than our moon. Europa is just a bit smaller. Ganymede is very much bigger, and actually bigger than the planet Mercury, and Callisto is nearly Mercury's equal in size. So they really are large bodies, and if they weren't drowned by Jupiter, they would be seen with the naked eye. In fact, 1 or 2 really keen-sighted people have glimpsed them. And they were known from the very early days of telescopic history. They were studied by the great Italian astronomer Galileo in the winter of 1610. He may not have been the first to see them. He was certainly the first to describe them in detail, and he even wrote a book about it. You can see there Galileo's actual drawings of the 4 main satellites that we now call the Galileans. And that was a very important discovery, because at that stage, no one was quite sure whether the Earth went round the Sun or the Sun went round the Earth. And many people said there was only one centre of motion, the Earth. And Galileo's discovery of those 4 moons showed that there were at least 2 centres of motion, because those things went round Jupiter. And just in passing, during Galileo's observations, he almost certainly caught a glimpse of the planet Neptune, but of course he mistook it for a star. So let's have a look now at the Jovian system. Jupiter in the middle. The 4 moons, the 4 big ones, go around Jupiter in paths or orbits which are practically circular. Io first, at 262,000 miles, in a period of 1 day, 18.5 hours. Then we have Europa, further out, Ganymede further out still, and then the outermost of the Galileans, Callisto, which is more than 1 million miles from Jupiter and takes 16.5 days to go round. But when you look at these satellites with a telescope, they generally appear to be more or less lined up, and that's a pretty typical view. And the reason there is that they move virtually in the plane of the planet's equator, and we're having an edge-on view. And we've got a model here to show what's meant. This, first of all, is a bird's-eye view of the kind you never do get from the Earth, and the pole of Jupiter is there in the middle of the disk. That's not what we see. What we do see is an edge-on view, so let's turn our cameras, and you will see what's happening. Now, the equator of Jupiter is coming up towards presentation, and the satellites are lining up. And that's the kind of view we get. But of course, they do move around Jupiter quite quickly. You can see their shifts from one night to another, and you can follow all their bits of behavior. They may be eclipsed by Jupiter's shadow. They may be occulted or hidden by Jupiter's disk. They may pass in transit in front of Jupiter. And it's quite fascinating to follow their movements, and you can do this with any small telescope. And remember, any small modern telescope is a great deal better than the one that Galileo used. But from Earth, the Galileans do look like nothing more than tiny disks. And it wasn't until the Voyager flights that we really found out what they were like. And they have proved to be very surprising indeed. And they are not a bit like each other. So let's have a look now at what Voyager's told us about the Galileans one by one, beginning with the outermost, which is Callisto, the faintest of the 4 and the least reflective, although actually the second largest and nearly as big as Mercury. And there's a Voyager picture, and you can see that Callisto is covered with craters, and the surface is icy. And so we have an icy, cratered world. And when you look at a map drawn from the Voyager results, you see there are 2 huge ringed formations. One we've called Asgard, and the other we've named Valhalla. and they dominate those areas of Callisto. And Valhalla really is spectacular. There are some of the cratered areas, and Valhalla's now coming in toward the top of the picture, a huge multi-ring structure, and the favorite theory is that that was caused by a missile striking Callisto in the very early days of its existence. But if so, Callisto has been battered, and there are so many craters there now, there seems almost no room for any more. It's a highly cratered world, and very cold indeed, at a temperature of something like minus 120 degrees centigrade. And Callisto appears to have a very old surface. The inside is silicate probably, surrounded by soft ice, and then the ice rock crust, which hasn't shown any alterations since the early days of its formation. And so Callisto really qualifies as a kind of cosmic museum, and nothing's happened there for thousands of millions of years. And if we ever do succeed in sending astronauts out to the Jovian system, I fancy that Callisto may be the first target, because unlike the other satellites, at least the inner ones, it moves a long way from Jupiter, more than 1 million miles, and so is clear of the lethal radiations that Jupiter emits. So let's come in now from Callisto and have a look at number 2, which is Ganymede, the largest of the Galilean satellites, and actually the largest satellite in the solar system. And here again we have an icy cratered surface, but there's a huge dark area to the upper right that we now call Galileo Regio, which I think is a very appropriate name. And superficially, Ganymede and Callisto look rather alike. But Ganymede does have certain features that Callisto doesn't, has strange grooved areas, and you don't get those on Callisto. And in fact, over the ages, Ganymede shows signs of more past activity than Callisto does. There again you can see is Galileo Regio. Nothing really has happened on Callisto since the very early stages. There must have been some internal activity on Ganymede, and we can see the results of that, but nothing happens there now. And the internal structure is probably much the same as Callisto's. Once again, you have a silicate core surrounded by ice and a rock ice crust. And like Callisto, Ganymede has no detectable atmosphere. So, at least, the two largest Galileans do have points of resemblance. But coming now to the next one, Europa, and we find a very different situation. And there's a picture of Europa sent back by Voyager, looking rather like a cracked eggshell. No craters, no mountains, merely a kind of baffling series of cracks. And Europa is indeed a map maker's nightmare. Just look at this. There's virtually no surface relief at all, and one part of Europa looks very much like another. Nothing can be more different from the icy cratered surfaces of Ganymede and Callisto. And even detailed pictures don't show very much more. So Europa really is in a class of its own, and that surface is undoubtedly a sheet of ice. And so why is it so different from the other Galileans? There must surely be a silicate interior, and outside that we have the ice shell and a smooth surface. But it may well be that that silicate interior is hot enough to melt the lower part of the ice shell and produce an ocean of water. And there may be an ocean below the icy crust of Europa. And this had led to a very interesting theory by two American astronomers, Squires and Reynolds. They point out that if there is an underground sea there, then when the crust is fractured for any reason, possibly by the impact of a meteoroid, then a certain amount of sunlight might percolate in, and the conditions there, in that invisible sea, just might be enough to support primitive life forms. And they suggest, therefore, that in the ocean of Europa, if it exists, there may be very primitive life. Well, certainly that's highly speculative, but we can't entirely rule it out, I suppose, and Europa is a very curious place indeed. But not, I think, quite so curious as the innermost of the Galileans, Io. Just look at this, giving rather the impression of an Italian pizza. And it really is a brilliantly red world, and it's an active one. And when Linda Morabito, one of the NASA investigators, was studying a Voyager picture on the 9th of March 1979, she saw a kind of plume effect coming from Io's limb. And instantly she realized that this was nothing more nor less than an active volcano. And we now know that there are volcanoes scattered all over Io. And when we make a map of them, they are very widespread. Just look at that. And some of those volcanoes are really active. Io, again, has a frozen crust, probably frozen sulfur and sulfur dioxide, and it's cold. But the volcanoes are hot. And when Voyager 1 passed by, one volcano, Pele, the first one to be detected, and you can just see it there at the bottom of this picture, was found to have a temperature of over 2 200 degrees centigrade. So it really is a hot spot. And there, all over that picture, you can see volcanic deposits. Now, when Voyager 2 made its pass, a few months later, Pele had stopped erupting. But another of the early volcanoes seen, Loki, was even more violent, sending material upwards at a speed of sometimes more than half a mile a second. And so just why is Io like this? Well, we've got to look first of all at the structure. Again, we have a silicate interior, but this time it's almost certainly molten. And outside that, we have a layer of frozen sulfur and sulfur dioxide, underneath which things are hot. But just exactly why is Io like that and Europa is so inert? Well, Io's path around Jupiter is not absolutely circular, and therefore the gravitational strains on it vary, and we also have to take into account the pulls of the other satellites. And it seems likely that Io's interior is churned up, so to speak, sufficiently to keep those volcanoes erupting. Although I quite agree that it's very strange that Io is so active, and Europa, which is further out, but not all that much further, is so completely inert. So Io's turned out to be a very curious place indeed. And more than that, we already knew that the position of Io in its orbit affects the radio waves sent out by Jupiter itself. And we now know that Io's volcanoes send out ionized particles, mainly of sulfur and oxygen. And these make up a donut-shaped torus that whirls around. And further out, we come to the plasma sheet, which extends to more than 8 million miles from Jupiter. And this also is fed by the Ionian volcanoes. So Io has a very marked effect upon the environment. And note also that Io is connected to Jupiter by a very powerful electrical current. And Io is immersed in Jupiter's own lethal radiation. So it must be just about the most dangerous world in the entire solar system. And I'm quite certain that no one is ever going to go there. But just why it's like it is? Well, we have ideas, but we can't say we really know. And we do need more probes. And before now, we'd hoped to have further probes to Jupiter, and one in particular, the Galileo probe. And this was due to be launched from the space shuttle, and it should have been on its way by now. But as we all know, the shuttle has been delayed by the Challenger tragedy, and the Galileo probe has not yet gone up. When it does so, and just when that's going to happen I can't tell you yet, it's going to be made up of two parts. There's going to be an entry probe, which will go into Jupiter's outer clouds and will send back information in the last seconds of its life before being destroyed. And the other part will be an orbiter. It will be put into a path around Jupiter and will go on circling the planet, making periodical close approaches to the Galilean moons and sending back further information about them. And it'll be very interesting to see just what's happened on Io. I've no doubt that Ganymede, Callisto, and Europa will look just the same as they did in 1979, but Io will certainly be different. And those volcanoes must have been erupting since a very early stage in the story of the solar system. And you know, when you look at those Galilean moons, it really does conjure up an amazing picture. From Earth, they look so delightfully innocent, 4 tiny specks of light. And before the Voyagers, we had no idea what they were really like. But we now know they're some of the most unusual worlds in the entire solar system. And it's fascinating to follow them, and you can do that with any small telescope. As they move around Jupiter, you can follow their eclipses, their occultations, and their transits. And even that's enough to show you that it's true, as one person said a little while ago, there is no such thing as an uninteresting Galilean. And since this is my last program of 1986, I think it only remains for me to wish you a very happy Christmas and New Year. Good night.